All right, so here's what I have. I have ice table, ICE, 2, 2, 0, oops, 0, a little off center there, minus x, 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 2 minus x, 2 minus x, 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 and that's all I wrote. Why did I write that? All right. 2 mole sample, 1 liter, so I have 2 moles of each, which is true at equilibrium, and what did we say it was? It was C. So at equilibrium, whatever x is, right? So let's say x is 0.5, these two will be the same, and these two will be the same, okay? But this would be greater than that, and CO2, wait, what was the answer? Okay, now, oh, okay. So, this would be our ice table. Here we go. Now, the K value is 1.5 times 10 to the third equals x squared over 2 minus x squared. Okay, so if we were going to set up an ice table and solve for x, this is how we would do it, right? So, you would take the square root of this, take the square root of this, and then you could solve for x. So why does it make sense that this is going to be greater than this? This is the whole ball game here. That's why I didn't look at that initially. This tells us what's happening. If K is really big, what does that mean? Favors products. So this must be greater than this. The top must be bigger than the bottom. You don't need to know the number. So these two squared must be bigger than these two squared. Does that make sense? So therefore x must be greater than 2 minus x. That's how you would do a multiple choice without, you don't really need to solve it. If this number was really small, then the bottom would be very big and the top would be small. But because that's really big, we know this is big, so as far as the choices are concerned, that must be the answer. All right, it's not, it can't be A because these two are the same. It can't be B because that's backwards. Again, this means at equilibrium you have more products, so B's not right. And then D, that doesn't make sense because there's 2 minus A. If they were all the same variable, then sure, but that's not going to be the case. Those are really typical. Really typical. So, let me make sure I'm explaining it good enough here. If this is a large number, you're going to have greater amount of products, less amount of reactants, right? Relative to each other. If it's really small, then the opposite is true. Now, if this was a short answer, you could solve for x and then plug it in, and that wouldn't be too bad. But this is exactly why we do an ice table, and I do an ice table every time there's an equilibrium reaction. So a reaction with the word equilibrium, I always do this. I write it down, then I reread the question and say, okay, how does this help me figure it out? The key here is this. Big number, these must be bigger than this. That's how I know the answer is C. So these are pretty common. So just don't forget, if there's a 2 somewhere, it becomes 2x, right? If there's a 2 here, 2 minus 2x. So, okay, 33. The answer is where are my answers? I've lost my answers. Is that all I did? All right, well, we don't have time for me to sit here and do them all, so we might have to just get back to that in the review class if I can't find the answers. What the heck happened to them? All right, so I have the multiple choice answer, but I didn't have my explanations done.
That's
So,
fine.
yeah, so I'm not going to sit here and it'll take me too long because I need to sit and think about it to make sure I'm explaining it right to you, so I don't have time to do that. So I'll read the answers, and then after school or tomorrow, I'll go and explain it. So here we go. 33 is C. 34 is B. 35 is D. 36 is D. 37 is C. 38 is C. 39 is C.
Oh.
And 40.
It's C.
Nope.
How many times are you gonna say C?
A.
Oh.
40 is A.
Oh, dang it.
So,
Oh, I chose one. I hate C.
again, let me do this later today. I'll go through it and write down my explanations for why it is what it is, and then I'll go over it either after school or tomorrow. All right. So you can put that away. Take out the other two sheets. So I need to write that down. What is it? 33 through 40. I don't know what happened to that.
3 of those right.
33 through 40, 16. Huh. Looks like I just didn't do it. All right. Cool.
Can I have pizza tomorrow?
What's that?
Yes.
Yeah, I'm getting pizza. What do you want? Cheese?
Mm-hmm.
Is that safe?
Yeah.
Plus, it's probably the healthiest option.
You need to buy 2 pizzas though. Cause we all eat like 2 pieces each. Yeah.
You guys better bring me some money. All right.
No.
Okay. So, here we go.
Yeah, you didn't pay for this bonus. We did. You actually want us to do this?
No. I think I can handle it. I
It's gonna
spend
make
money
too
on
big of a
stupid
dent.
things, so that's not stupid. So here we go. All right.
If that's the case, we'd like wings for that. And
I'm
garlic
not
knots.
kidding. Listen, I'll draw the line at pizza. I mean, pizza is pretty unhealthy, but there's some healthy-ish parts to it. Wings, there's literally nothing. The protein in the
What about
chicken,
garlic?
even
The
if it's real,
chicken?
but it may not be real chicken, so I don't know.
What does that mean? If it's on the bone, I'm pretty sure
Yeah,
it's
wait a minute.
real chicken.
What?
You just mold it on there and cook it. Is that what you do?
Is it 2002 Form B? Look at the top.
No.
Or just 2002?
Part A.
Just 2002.
Okay, 2002, question 2, right?
Yes.
That's one of
Question
them.
1.
Question 1.
I lied.
Question
Yeah.
1 and question 5 on
1, 5.
2002.
So I want to do thermo first.
So
Okay,
5.
then question 5.
They're both on the same test?
I don't know. You tell me.
Yeah, here we go. All right, here we go. So the reason I gave this to you, and this is the last time I'm going to explain something like this. I hope there's one on here because I feel like I've stressed this more this year than ever before. If they mix an acid and a base, it's going to release energy. They may ask, they have all types of questions they could ask. Hopefully, if they ask this, it's a 1-to-1 ratio, HCl and NaOH, like this one. If it isn't, so just beware. If it's, let's say, HCl and CaOH2, just don't forget. Just don't forget you need 2 of these for every one of those. So when you figure out your moles of the acid and the moles of the base, this is really the limiting, essentially, because you need twice as much of it, right? So typically, they give you the same amount of both. So I just want you to understand, you get your moles here, and that's going to help you figure out what your delta H is, right? Because Q is just joules, delta H for the 400th time is joules per mole or kilojoules per mole. All right. So anyways, this one's easier. It's all 1-to-1-to-1. Part A, I hope there's something like this, right? You cannot get this wrong. You shouldn't. Q is joules, M is grams or kilograms. You can put kilojoules, I suppose, for Q, but really joules is supposed to be the answer. C, now C is on your equation sheet, isn't it?
No.
They don't give it to you?
It just says specific heat capacity.
It doesn't give you the units?
No.
Okay. So I guess to be fair, you could make a mistake here. It's joules per gram Kelvin or joules per gram degrees Celsius. If you get confused, if Q is joules and mass is grams and temperature is Celsius or Kelvin, you need this unit to cancel out grams and Celsius and leaving joules.
Wait, is temperature Celsius or Kelvin?
Doesn't matter. You can do joules. So if this is Celsius, that's Celsius. If this is Kelvin, that's Kelvin. So the Kelvin cancels, grams cancel, you're left with joules. I know that's something Mr. McConnelly stresses, and I've tried to emphasize that this year. You can figure out units to numbers or answers based on what you're calculating. Just figure out what it needs to be or what cancels out. Anyways, that's A. B. Okay, how can we get the value of Q, right? So you're pouring the acid and base in a calorimeter, right? So now in here you have your HCl and NaOH, which makes salt water. If we want to figure out the Q of the water, we need the volume. So we need the volume of this solution, which ultimately gives you the mass, which is M, right? So that's one thing you need. You need the initial temperature before you mix them, right? Because one of them, let's say, the base is in the container. So you need the initial temp, then you add the acid, get the final temp. So now you have your mass and your delta T, that's your M and your T, right, delta T. And then that's it. That you know specific heat. That's all you need. You need the mass, which is the volume. So the density is 1 gram per milliliter, and then you're changing temp. Just remember, this value will be negative because it's releasing it. The temperature should go up, right? So the reaction, the delta H is negative, but the value of Q is positive because the Q is the water, which is absorbing the energy from the reaction. So Q is negative, but Q is positive, but the delta H would be negative. All right. Explain how to calculate the following: number of moles of water formed during the experiment. So if we have HCl and NaOH, that gives us NaCl and H2O. This is easier because it's all 1 to 1 to 1. So all you would need is to calculate your moles of acid or base based on the stoichiometry. That would give you the moles of water. So what do they want you to show? So explain. So you didn't actually have to show like set up a calculation. They didn't really give you any numbers. All you would have to write is find the moles of acid or moles of base. Since it's 1 to 1, that tells you your moles of water. That's it. That's all you would have to say. And that's what they have.
Doesn't matter which one you use?
Nope. Because they both are going to react exactly how they need to neutralize.
Okay.
That was a problem we did a while ago. And that's if this was CaOH2 or H2SO4, even though the ratio would be a 2 to 1 ratio, they would still react with the same moles of each.
Okay.
In other words, it can't produce water unless you have 1 H plus and 1 OH minus. So one of them would be limiting, one of them would be excess, but the moles really wouldn't matter as far as which one you use.
Okay.
I guess my advice on that is if you need to use a 2, so if it's H2SO4 or 2 OHs, when you balance it, find the moles of both of them and find which one's limiting. Use that number.
This one's limiting?
Yeah, you should always. This is, so make sure everyone's listening here. Any reaction where you have to find the amount of products, I don't care what kind of question it is, acid, base, precipitation, whatever. If you have to find moles of products or mass, you definitely need to find limiting. It's not going to always tell you to do that. That's something you just need to know. Always use your limiting. Limiting is the only one that affects the products. The excess is excess, so it's not going to all react. So, I think, didn't I give you a limiting problem in one of these worksheets?
I don't know.
Part of it? I thought so. On the other side, maybe? Or
I
the other
know
one?
what it was.
We're going to do a limiting problem. If not now, after school, tomorrow, we will do a limiting problem. I was going to do it with precipitation. All right, now, molar enthalpy of neutralization. They're nice. They said molar enthalpy. They don't have to do that. They could just say enthalpy. Molar, they're telling you you need to use the moles, right? So, once you find Q, these are almost harder because there's no numbers, right? I feel like they might be harder. So, once you find the Q, what's that? That's how much heat the water absorbs. You take Q and you divide it by the moles. That's how you get delta H. That's the answer. That's it. That's all you would have to write on the test. You take your Q, divide it by the moles. But remember, this would have to be negative. I'm not sure. Are they going to take points off of that? Let's see. Determine the quantity B. No, they took either one. They had negative Q or positive Q. Doesn't matter. So once you find the amount of energy involved of the water, you divide by the moles. So this is the energy of the water, and this is the moles of the water, which is the same as your moles of acid or base. So really, you just need to write the word moles. I really tried to emphasize this. I hope this is on there. I don't know if you feel the same way, but we've done this maybe 4 different ways, 4 different types. This is another type, just because I know I wasn't good at reviewing. I didn't do a good job teaching this in the past. I went through it too quick, so I'm really trying to stress, if it's an acid-base thermo question, the Q is for water, then you divide by moles to get delta H. That's all you really need to remember to get the end result. Of course, there's other steps you need to remember. But. All right, that's it, right? Oh, no, there's a whole, what are we going up to? All right, here we go. Ah, what do you guys think? 2 moles per liter. So we double the molarity. Does Q increase, decrease, or stay the same? What do you guys think?
It stays the same. Because the big M does not affect
The big M.
the, wait, right, is it big M? Yeah. The big
Yeah,
M
you're
does
right.
not affect the, what's it asking for? The Q. It probably does. It probably increases. Does it increase? It increases.
Q increases.
Big M
Why?
affects it.
There's more moles. More moles react. So just think of it very simply. You know, if you burn 1 piece of wood or 10 pieces of wood, the 10 pieces are going to produce a hotter, bigger flame, right? More energy. More energy for more fuel. Same concept. More moles reacting, it's going to produce more energy. However, your delta H stays the same. Your delta H stays the same. Q will go up, delta H stays the same.
That's what
Why?
I was thinking of.
Because if this is increasing, because this increases, if they both increase, and it's proportional, because whatever this does, this is going to change proportionally, this will never change. Does that make sense? That's important to understand. When you have more particles reacting, there's going to be more heat produced. So that's Q.
Yeah.
But when you take in the extra moles into account, you're dividing this by a larger number, so delta H actually stays constant. Heat of neutralization for reactions is a constant. Look them up online in the book. So whether you react a molarity of 2 or a molarity of 1, whatever the molarities are, it is what it is, because this will cancel out each other. So the delta H stays the same. That's kind of a tough question. I guess another way to explain it is the delta H is kilojoules per mole, right? So per mole. So even though let's say you react 500 moles of each one, this will reduce it down to, what if I have 1 mole? Well, this number is a constant because of that, because it's always per 1 mole, because this changes proportionally to that. So that's always going to be the same for this type of reaction. Okay. Where am I? Oh, if you lost heat to air, what happens? What is it asking? What would happen to the delta H? So, what do you think? So if we lose heat to the air, what's going to change here?
The Q.
Right. So the delta T would be a smaller change. Not all the energy would go into the water. So that means Q would be smaller, so what happened to delta H?
Decrease.
Yeah, decrease. Okay. Do you have to explain? Yes. All right, so the way to answer that on an AP test, you would say, if heat is lost to the air, Q will be smaller, which results in a decrease in delta H. So you're answering that, and then that's your justification. You're saying the Q is going to be smaller. It doesn't look like you have to say delta T is smaller. As long as you say Q or delta, one of those two. That's what it says. Alright, go to the other one. Is this the acid base one?
Yeah.
Alright, good. We needed to do one of these anyway. Alright, is this the hypobromous acid?
Yes, it is.
Chances are it's going to be some squirrely acid that I don't really use in class or the book doesn't talk about. So hopefully you can at least understand HA, right? So you have your H, then your A minus, so you got your H and then OBr minus. There's your Ka. It's a weak acid, obviously, really small Ka. Calculate the value of delta H in a solution that has a pH of 4.95. How do we do that? Right, pH equals negative log of H plus, so you just do 10 raised to the negative 4.95, or second log on your calculator, but remember it has to be negative. 10 raised to the negative 4.95, so H plus is 1.1 times 10 to the negative 5. Okay. B, write the equilibrium expression, then calculate the concentration of HOBr in a solution that has an H plus equal to 1.8 times 10 to the negative 5. Ka is equal to H plus times OBr minus over HOBr. What are we looking for?
The concentration
This?
of HOBr.
Okay. Ka is 2.3 times 10 to the negative 9 equals 1.8 times 10 to the negative 5, and that's going to be squared. Why?
Because there's two things on top.
Right, but
They're
just
the same.
yeah, they're the same. So this is where you could do an ice table. You could.
It didn't work for me.
Okay, so if you do an ice table, none of this initial stuff matters. What it's asking is, what is the equilibrium concentration of this? They told us this concentration is 1.8 times 10 to the negative 5. Since it's 1 to 1, they're both going to be the same. So it is important, by Thursday morning, you understand how to fill these out. So if you don't, please tell me and we'll just do more of these. So again, it doesn't really matter what the initials are. This would be minus x, 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 so everybody's x. Actually, technically, it would be, that's how we used to do it. Question mark is like the original, x is the change, so that you're going to have to subtract. But anyways, that would be the ice table. So there's my x there. So whatever they get here, 0.14. 0.14. So to be clear, the original concentration is different than what they're saying here. Just to be clear. So this is the equilibrium concentration, 0.14. Because that's what this solves. This is equilibrium. They're not asking for the original because that would be the original minus the change would equal your concentration. But that, I'm not trying to confuse you, just that's what this is telling us. This tells us the equilibrium concentration. Alright, 0.14 was the answer. Alright, part C. Solution of barium hydroxide titrated in a solution of HOBr. Calculate the volume of 0.115 molar equivalence point when titrated into 65 milliliters of 0.146 molar HOBr. So I would write out the balanced equation for this. Because at equivalence point, moles of H plus equal moles of OH minus. So if this is our reaction here, what do we get? Let's write the balanced equation. BA, oops, OBr2
Oh, yeah.
plus what? HOH. So we need 2 of these,
No water.
and that's it, right? So it's a 2H plus to 1, sorry. 2 of those to 1, because 2 of those will equal 2 of those, right? So if I have 1 BaOH2, That's the relationship there. So I need twice the moles of the acid is the moral of the story. 1 mole of this is 2 moles of this is what I'm trying to say. So, alright. So now what are we doing here? It says we have how many moles of the acid do we have? So let's figure that out first. We have see, they're doing it all in one step here. So basically what we need to figure out is how many moles of this we have, right? And then you need half of that, right? So mole, it's a 2-to-1 ratio, and then you multiply it by the molarity to get the volume. So they're telling me we have, what's 0.146 times 0.065? So that's what we have to do. 0.146 times 0.065, because that's the molarity of this, and that's the volume. I want to get the moles of that. So I'm going to do that for me quick here.
0.00949.
Okay, that's moles of HOBr. That's the volume of this. It told us 65. That's the molarity of this. You multiply them to get the moles. So, we could do a very simple proportion, 2 to 1, 0.00949 to x, right? So if I have 2 moles of this, I only need half, right, 1 mole. So essentially I need half of that number. So half of that number would be, again, they did it all in one step here. Just divide that number by 2.
0.0047. That's as far as you're getting.
3 sig figs is better.
Oh.
0.0047 moles.
4.
Now, whatever. They divide by the volume now, right? What's the volume of, or not divide? Yeah, divide. So let me rephrase that. So what's the molarity? 0.115 is the molarity. We have 0.0047 moles. What's the volume, right? Molarity equals moles over liters. That's just one way to do it. Essentially, you're dividing this by that. That's another way, because think of it this way. You have 0.0047 times 1 liter over 0.115 moles. That's another way to think of it. Moles cancel. So 0.0047 divided by 0.115, that's the volume that you need to neutralize that. So whatever that is, they said 41.3. So we should be close to that. Yeah.
Hey, your decimal's just over 2.
So the reason I assigned it, 1, it's good to practice the KA stuff, and just to understand, if it's not a 1-to-1, and it might not be, you got to use your coefficient to figure out the moles at equivalence point, right? So even though I've said a million times H plus moles equals OH minus moles at equivalence point, it's not really true because it's based on the stoichiometry, right? We just kind of proved that you have this many moles of HOBr, but you only, I mean that is true, but you only need half as many moles of this because that will produce 0.00949 moles of OH minus. That's another way to say it. So this many moles of BaOH2 produces this many moles of OH minus because there's 2 of them. So at equivalence point, H plus moles equals OH minus moles every time, but just be careful with the stoichiometry. I hope I'm being clear and not confusing you. The moles of the compound will be half, but that produces the exact same amount of moles of H plus because there's 2 of them. That's the trick that I don't want you to get tripped up on. Not trick, that's the concept. I would like it if they give you just 1-to-1 ratios, but. Alright, now, is the pH less than 7, equal to 7, or greater than 7? And explain. Now, it doesn't say you need calculations. There's one answer with a calculation here, but I don't think you need it. Does it ask for the pH? No. What do you guys think?
Greater.
Why?
Because it's a weak acid.
Weak acid, strong base. Strong base is group 1.
Genius.
Group 1, group 2 with OH is a strong base. They told us this is a weak acid. They told us, so I'll give you, I don't know if it's a hint or if it's just kind of a trick. If they tell you one of these is weak, the other one's going to be strong. They're not going to give you a weak acid, weak base titration. I don't think we've ever really done that. I mean, I suppose they could, but that would be very difficult. So I don't think that's going to happen. So weak acid, strong base, pH is going to be above 7 at the equivalence point. And why is that? You could say because this is a strong base, weak acid, when it reaches equivalence point, it's above 7. That's good enough. But I'm going to take it one step further. What species is present that makes the pH higher than 7?
OH minus.
Nope, okay.
At equivalence point, hold on. At the equivalence point, your moles of H plus and your moles of OH minus cancel out to water. So all there is water with respect to this and this.
Oh, so because you have the
Conjugate base.
Strong conjugate base. That's why the pH is above 7. Okay? At equivalence point, you really should have just water with the H plus and OH minus. That's the whole concept. But because there's a conjugate base sucking up H pluses, it's going to bring up the pH a little bit. Could you guys find the KB? I'm just trying to think of something else to help review here. Could you calculate the KB of the OBR minus?
Probably not.
Let's talk about it.
Wait,
How would we do that?
okay. The KB?
Yeah.
Hold on, let me get out my,
KB for OBR minus. Could you guys calculate it?
hold on. KB is OH minus plus AP plus OB. So,
I'm just going to answer it for you.
yeah, KW equals KA.
Times KB.
Yeah, that time.
So, if this is a times 10 to the what?
And also what I did.
What is this? 9?
Negative 9.
Yeah.
Yeah. And this is negative 14. This is going to be,
Oh.
it's not exactly negative 5, but in a perfect scenario, that would be negative 5. It's actually a negative 6. The point is, what I'm trying to show you is if it's a weak acid, your conjugate base is going to be stronger. It's going to be a bigger number. That's how you can prove it. Just refreshing your memory there. What else did I want to add? There was something I thought of yesterday. I know we're not done with the problem yet. Here, let's just finish the problem. All right, D. Calculate the number of moles of NaOBr that would be added to 125 to produce a oh, here we go. Buffer solution.
I
All right.
remember how to do this, but I couldn't get out the...
So a buffer is a weak acid and its conjugate base, or the other way around. So if you have HOBr and then Br minus, or the other common one is ammonia with NH4 plus, so the base with the conjugate acid. Another way to explain that is you have a weak acid and its salt. The way the salt gets in there is they do usually sodium or potassium, like a ionic solid. So inside the container, if it's a perfect scenario, you have equal concentration. So let's say this is 0.1 and then this is 0.1. So that would be a perfect scenario, and when that is achieved and you're right here, halfway to equivalence point, pH equals pKa, but only when these two are equal. And that's because of that equation, pH equals pKa plus the log of A minus over HA. Those cancel out, so you end up getting this. So I know I just went through that quickly, but that's the buffer concept. This reacts with bases that are added, this reacts with acids that are added. So anyways, how many moles of this, the NaOBr, would have to be added to 125 of 0.16 molar HOBr? So we have 0.16 is the molarity of this, and we have 0.125 liters. Okay, so how many moles, let's see, to produce a buffer with an H plus, okay, why do they give us the H plus concentration?
To throw you off.
No.
Because you can find
What
the
can you
B,
get from?
the other one.
You can get the pH from it. Okay, good. There's actually 2 ways to do this.
You
Am I
can
gonna
put
run out
OH
of time?
minus.
I'm gonna run out of time.
You can
Well,
find
all right.
minus.
What's the
Q.
what's the pH? Let's just do that. What's the pH if your H plus is 5 times 10 to the negative 9? Someone do that for me.
Oh.
It's just like letter A, right? Or B? What was it?
Oh. It's to the negative 5.
Just like-
to the negative 5.
It's A, except easier.
Yeah.
It's a negative log of that number. What is it?
It's something to the negative 5. Come on.
What?
Negative log of 5 times 10 to the negative 9. 1?
I got 8.3.
That makes sense. 8.3. All right. I'm going to have to stop. So, those 2 sheets are due, and I will copy tomorrow, and I will copy 20 multiple choice on the 2018 test. And just a little disclaimer, remember, I need all this stuff back. You can't keep it. I gotta keep it and shred it. Yeah, I'll be in there 5th.